Hello, we're in Chapter 3, Section 3, Solving Systems of Linear Inequalities. I'm going to do the guided practice problems that are just like the homework problems that you're going to be seeing, just different. Same type, just different numbers. These are on page 202 from the textbook, which is PDF page 25 if you're looking at that. And we're going to do problems 2, 3, 4, and 5. Let's get started. Problem number 2, both of these are in slope-intercept form. So my boundary line is y equals 4x minus 4. My slope is 4 over 1. I'm going to try to squeeze it in here. And my y-intercept is negative 4. So that tells me to go down here to negative 4. And my slope is 4 over 1, so I'm going to go 1, 2, 3, 4, and right 1. Up 4 and right 1. And this is a solid line. And again, I know I'm going a little fast with this. That's because we've done this before. You can rewatch the 2-5 videos if you're confused by this. I'm going to shade above that line. So I know I'm going to shade on this side. I'm just going to make little marks here telling me which side I'm going to shade. For the second inequality, the boundary line is y equals 3x subtract 3. My slope is going to be 3 over 1, and my y-intercept is going to be negative 3. I never liked this problem because it's going to end up looking like this. Here's negative 3. I'm going to go 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. I never liked this problem. I don't know why they picked it. I should have changed it. But I have a solid line. It's not exactly the same, but it's really close. And that's, I even missed it right there. And that's what it looks like. And I'm going to shade above this one. So the overlap is going to be this area right in here. I got like a really skinny wedge right here and here, and then I got this open space. I should have just ignored that problem. That's what I should have done. We'll have better luck with the next problem. I never liked that problem. All right, this is in standard form. So I got x plus y equals 5. That tells me that if I let x equal 0, I get y equals 5. And if I let y equals 0, I get x equals 5. This is a dashed line. So I'm going to draw my dashes like so. And I could pick a point on this side and pick a point on that side. When I get that done, I'm going to realize that I'm going to be shading above this dashed line. Okay, now the other one. My boundary line is x subtract y equals negative 3. If I let x equal 0, I get negative y equals negative 3, so y equals positive 3, which is right here. And if I let y equal 0, I get x equals negative 3, which is over here. This is also a dashed line. And this one is going to be a little tricky. You would think that I'm going to be less than, but it's not. If you pick a point here and pick a point here, you're going to find out actually that you're going to shade above the line. And the way that I know that is because of the negative sign in front of the y. If I put it in point slope form, or slope-intercept form, excuse me, slope-intercept form, I'd have to divide both sides by negative 1, which is going to flip that sign. So this is actually going to be above this boundary line, and that tells me that that overlap is this area right there. And of course, I know we didn't draw a lot of it, but we know where it's at. All right, I'll quickly try to do these last two. Problem number 4, this is not slope-intercept form, it's not standard form. So I'm going to try to make it into slope-intercept form. First of all, I want the y on the wrong place. I want the x in the wrong place. So I'm going to flip the whole thing around. I'm going to write y subtract 16. However, this part, the y subtract 16, that's where the alligator is eating. So the alligator is still going to be eating that part. So I got to flip the symbol too, from less than to greater than. And then over here I got 7x. Okay, now I'm going to add 16 to both sides. I'm going to get y is greater than 7x plus 16. All right, that's not very helpful because my graph didn't go up to a y-intercept of 16. Okay? So one thing that I can do is I can say, what about if I let x equal 2? All right? Or, excuse me, negative 2 is what I meant. 7 times negative 2 is negative 14, and negative 14 plus 16 is 2. So negative 2 is going to be on that line. Okay, that's good. I could try negative 1. I would get 7 times negative 1, which is negative 7, which is going to be 9, but that's going to be off my graph. And my slope is 7, so I'm at 1, 2, 3, 4, 5, 6, 7 off the graph. I can try going the other way. I can also try letting x equal negative 3. 7 times negative 3 is negative 21, and negative 21 plus 16 is negative 5. So that's going to be right here. And again, my slope is 1, 2, 3, 4, 5, 6, 7 to the right 1. Okay, really complicated one with that, but we were able to figure it all out. Dashed line. So I'm gonna use my ruler for this one. I can't follow the grid to do it. Dash line, dash, 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 dash. And again, this is where using the Desmos, the technology, is going to be very, very useful. And right here, which is in slope-intercept form, I know that I'm going to shade above it. So I got this part right here. That slope is 7. 7 doesn't seem like a very big number, but it makes a really steep line. For the other one, okay, thank you. This one's kind of nice. My boundary line is y equals negative 5x subtract 2. So I get negative 2. My slope is negative 5, so I go 1, 2, 3, 4, 5, going to go down that way, and it's going to be off here. Okay, so I know it, oh, excuse me, it's right here. I know it's off the grid a little bit, but I know it's actually down there, so when I draw it toward that point, I'll be okay. I can also go the other direction. 1, 2, 3, 4, 5, and left. So I'll try to draw that, and this one's going to be a solid line. Like so. Okay? And I know I'm going to shade below that. So the overlap is going to be above this boundary line, but below that boundary line, which is going to be this area over here. Okay? And I think that's a good one for me to switch back and show you Desmos. I wasn't going to do this with all of them, but I think that's a good one for me to do. Sorry, I bumped my paper. Okay? So I'm going to put it in exactly as you see it. 7x is less than y subtract 16. Okay, so compare this. I'll move my paper. Compare that with that one right there at the dash. Looks like the same thing. All right? For the other, I get y. I tell you, I don't like using this pop-up keyboard. Negative. There's nothing wrong with it. It's just things aren't where I'm expecting them to be. I'm so used to the other thing. Okay. So now, look what I've got. Those look the same. And because I had this grid that was like a 6, 6, negative 6, negative 6, now with, it's hard to see that. Now with Desmos, I can move around and get a better look at what's happening. You can like pinch it or move it around like that. Okay? So use Desmos as a backup. Let's do this last one and then we'll move on to the next video. So my boundary line is, these are in standard form, 2x plus 2y equals 4. If I let x equal 0, I get y equals 2, which is right here. If I let y equals 0, I get x equals 2, which is right here. And it's a solid line. So I'm going to draw my solid line right through here. And again, you can convert it to slope-intercept form, or you can pick a point on either side. This one looks like I'm going to be shading below it. For the other one, 3x subtract y is greater than 1. Oh, sorry. Yeah, sorry. I should do it. Well, that's okay. If I put this in slope-intercept form, I'm going to get negative y is greater than negative 3x plus 1. And then I'm going to multiply or divide, either one works, by negative 1. I get y is less than 3x. Subtract 1. So my y-intercept is negative 1. I almost put it in the wrong place. And my slope is going to be 3. 1, 2, 3, right 1. 1, 2, 3, right 1. Now I know that I started out in standard form. It just makes it a little difficult. I know that negative y equals 1. So y equals negative 1. That's what I have here. That's my y-intercept. But then if I let y equal 0, I get x equals 1/3, which is going to be like right about here. And that's kind of hard to graph. And these two were kind of hard to figure out where the rest of it's going to go. So I'm going to use all the tools that I have. And that's dash. So I'm going to draw my dash line between them. And if I look at this one, which is in slope-intercept form, I'm going to be below. Why was it greater than here but less than here? Because when I divided or multiplied by negative 1, the sign switched. So I'm actually going to be below here. And that tells me that I'm below both lines, which is this area right here. Okay, make sure you use Desmos as a backup. All of this stuff is stuff we've done before, too. All right? See you in the next video.